Good morning. We're on to lesson 3 notes on our last unit. So we're going to talk about polynomial regression. This is the same idea as the other regressions we've done. We've done exponential regression, logarithmic regression. The only difference really is that button you choose in your calc menu. You're going to make sure you're going to do a polynomial regression instead of exponential or logarithmic. So I won't go through all the details of regression. You know, basically you're collecting data, you're a scientist, and you come up with a bunch of data points. You can enter those points into your calculator, and then you can use your calculator to come up with an equation to describe the points that you plotted. So let's look at the first example here. It says the concentration in milligrams per liter of a medication in a patient's blood is measured as time passes. Susan has collected the following data and is attempting to express the concentration as a polynomial function of time. So here we have our information, we have time, we have concentration. It says plot the data on the grid to investigate the type of relationship between concentration and time. The only thing with polynomial regression is there's 3 different options you can choose. It might be a linear regression, a quadratic regression, or a cubic regression. So there's 3 different buttons. So sometimes I'll tell you which kind of regression it is, and you'll know. Other times you might want to plot the points and see which one would make the most sense at the time. So we're going to plot these points here. I'm going to do time at the bottom. And we're going to determine what kind of regression will most likely match the data. We're going to do concentration here. Okay, and then we're just going to plot each of the points. So for time 0, your concentration is at 0. At 1.5, it's at 26.9. So about here. At 3, it's at 41.2. So about there. 4.5, it's at 47.8. It's a little too big for my screen. So 4.5, it's at 47.8. Then at 6, it's going to be at 46. 7.5, it's going to be at 36.8. And then at 9, it's at 20.3. So here's the data that I'm given. I've plotted it on there, and now I can kind of determine what regression I need to use. So we're going to look at part B, select the best alternative for the type of relationship. Constant would look like a flat horizontal line, so I know it's not the constant one. Linear will be a straight line, like a ruler, but at an angle, and it's not quite like that. Quadratic is like a parabola shape, either opening up or down. And I can see right away looking at this shape, it looks like an upside down parabola, so it's likely that I want to do a quadratic regression for this information. And then cubic, it starts at one end, does a little zag, and then carries on. And it's not quite like that. So I know I'm going to use a quadratic regression for this information. So let's go on to the next page. We're going to continue on with this data, but actually perform the regression and figure out the equation that describes that information. So this is the same chart as we had on the previous page. So now we're going to go through and come up with the equation for the line. So remember, we have to go into stat, edit. You'll see on your sheet there. I'll show you on the calculator as well. And you're going to put this in your list 1 and this in your list 2. So we're going to do that first to get a watch me do that. You're going to go on your calculator. You're going to go to stat, edit. Here's your lists. You probably have stuff in there already from previous stuff. So highlight the top, hit clear, and then hit enter. Do that for both lists to clear them. And now I can enter in my L1 data. So I have 0, 1.5, 3, 4.5, 6, 7.5, and 9. And then I'm going to go to my list 2, and I'm going to put in the concentration. 0, 26.9, 41.2, 47.8, 46.0, 36.8, and 20.3. Now I've entered it into my calculator. So the next step is I'm going to find the equation. So now that it's stored in there, you're going to go back into your stat menu. And now you're going to go over to calc. And now these are all your different options. We've done the exponential regression. We've done the logarithmic regression. Now you'll notice you have 3 different options here for polynomials. You might choose the linear regression, you might choose a quadratic regression, or you might choose a cubic regression, depending on what I'm asking for. And I might ask for the specific one, or you might have to look at the data or the information given and decide which one would be the best one. So we are doing quadratic, that's what we figured out before, so I'm going to go down to the 5th one. Hit enter, I'm going to do my quadratic regression. Now again, you're going to want to store this exact equation into your y equals part so you can graph it without having any errors. So if you have a newer calculator, you'll have this screen here. If you have your old calculator, it'll just say, I think, calculate or something like that. And you're going to, if you're on your new calculator, go down to store, and you're going to go vars over enter, enter to store your equation into your y1. If you have an older calculator, you're just going to go straight into your vars and do that right there before you hit enter, and then you should be able to calculate. So let's hit calculate. Now you can see it gives us our quadratic regression, and it tells you what your equation will look like and then what each of your values are. So I can see what A will be, what B will be, and what C will be, and I can just put those into that equation and get my quadratic regression. So that's how I got the answer for A. Remember, we did a quadratic regression. And it says, make sure you watch how I want it rounded. So this one round to 3 decimal places. So I'm just going to write those values in here. And this one is done. Okay, then ask more questions, and we have to kind of analyze. It says graph the regression equation on your graphic calculator and use the graph to answer the following questions. So we already stored it into our y by doing that vars button. So when I go into y equals, it's automatically stored in y1 already. I'm going to delete y2, that was from something earlier. And then I always like to look at my window. You can tell what you need your window to be at by looking at your chart. So my time goes from 0 to 9. So my x, it's I might go negative 10 to 10. That's going to include all my values from 0 to 9. My scale, I'm going to change back to a 1. My y, I can see it gets up to 47.8, so my y should go at least up to 50 in order to see all the data, and I'll change my scale to a 5. It doesn't really matter for scale. When I graph it there, you can see your quadratic regression. Okay, so now we can do part B where we have different questions. So the first one says determine the x-intercept of the graph and explain what the value of the x-intercept represents, round to 2 decimal places. So when you want to find the x-intercept, it's where the graph touches the x-axis. So in other words, when you go into your calc menu, there's a function called 0 that you can click, and that'll tell you your x-intercepts. So let's do that. So I'm going to go to second calc, and then I'm going to go down to 0, and it wants me to calculate the 0 of the function. Oh, mine's almost off the screen. Maybe I'll make my x value a little bit longer in my window. Let's say 15. Okay, so now we're going to go second calc to 0. And I want to figure out what the 0 represents. So we're going to go slightly to the left of the 0. I'll get there. There we go. Hit enter. You want to go slightly to the right. Just lets your calculator know where to look for the 0. And we're going to do a guess. So this is right where it touches the x-axis. And I can see my 0 is at 10.159, etc. And remember, when you see something like this with the e there, it essentially means 0. It's just off slightly, like a minuscule amount. So we found our x-intercept. It's at this. So my value for x, it says around 2 decimal places, is going to be 10.16. But make sure the question wants you to interpret what that means. So if you think about it, looking at this chart here, this is the medication in somebody's system. So as soon as you take the medication, the amount in your system increases until it reaches a certain point, and then it starts to work its way out of your system until there's nothing left. So if you look at where that x-intercept is, it represents where there is no longer any medication left in your system. So that's how long it takes for the medication to work its way through. And that's what I wrote in the question there, so I won't rewrite it now. Part 2 says, determine the coordinates of the vertex, the maximum point, and then we have to explain what the vertex represents. So it already tells you it's the maximum point, but if it didn't say that, you could look at your graph and see that your vertex would be a maximum. So you're going to go into second calc, and then go down to maximum to calculate the vertex. And again, vertex is at the very peak. So first you have to go a little bit to the left of the peak. Doesn't really matter how far. Enter, go a little bit to the right, hit enter, and then take a guess. That'll tell you what your maximum point is. Gives you your x and y values, so you can write that down and then interpret what does that actually represent. So here I went to calc maximum. So you can see for your vertex, it's at 5.05, 48.57. What does that actually represent? And I wrote it in the notes there. It's the maximum concentration of medication in the patient's blood, and it occurs 5.05 hours after taking it. So that's when your drug is going to be most effective, is about 5 hours after taking it. It reaches its maximum concentration in your blood, so it should be taking in full effect then. Okay. Provide the domain and range of the scenario described given the information above. Your domain always pertains to your x values, all your applicable x values. So looking at my graph, I can see technically if it was just a plain old parabola, I'd say x belongs to r because those lines keep going down and over, wider and wider forever. But in the context of the question, it doesn't make sense to have x values that are negative, right? Like time is not going to be negative, and it doesn't make sense that your medication is going to be less than 0 in your blood. So in the context of the question, the only values for x that are valid are the ones, I'll change the color here, between here and here. These x values here are the only ones that make sense in the context of the question. So when I write out my domain, it's going to be x such that x is going to be between 0, and you know what this point is already right here. So that x-intercept you figured out earlier, so we might as well use that information. It was 10.16. So for my domain, my x is going to be all the values between 0 and 10.16. So in other words, all the time that occurs between 0 and 10 hours later, because that's when the medication is actually in your blood. Range has to talk about your y values. So a similar idea, we're going to look on our graph here. My y values, you can see the highest my y will be is right at that vertex, which we figured out is 48.57. And the lowest my y, my concentration will be, is technically at the 0. So this is the range that you'll see is applicable in the context of this question. So my range is going to be y such that y is between 0 and 48.57. That's the domain and range. Okay, a couple more questions. Determine the concentration of medication in the patient's blood after 5.8 hours. So it's basically telling you that your x is 5.8 hours. So all you have to do is go into your calculator and go calc value, and it'll tell you what your y value is at that point. So I'm going to go in here, I'm going to go second calc. I'm going to erase my lovely drawing. And I'm going to go to value, and I want my value when x is 5.8. I'm going to hit enter, and you can see it gives you your y value or your concentration. It's going to be 47.5. Make sure you include units if they are applicable to the question. I haven't been taking marks off for that, but it is something that you should be aware of. Okay, last question. The doctors decided that the patient needs a second dose of medication when the concentration in the blood is less than 10 milligrams per liters. We want to know how many hours after the first dose should we give the second dose. So in other words, I want to see on my graph, when does my Y get back down to 10 milligrams? Because once that happens, I need another shot of medicine. So when you have a Y value and you're trying to find what your X is, you have to do a little bit more work. You have to find the point of intersection. So we're going to go back in our calculator, and under my Y2, I want to put 10. And then I'm going to see where these two intersect. So let's graph it. And again, we want it when the medicine drops down to 10. So I know there's 2 points on the graph that occur when your concentration is 10, but we wouldn't give it at the first one because my medication is already still increasing at that point. We want to wait until it's dropping down to 10 milligrams before we give more. So basically, I want to find that point of intersection there. So we're going to go second calculate. We want to go down to intersect. First curve, second curve, you can just hit enter. Enter, there's only 2 curves here, and then make a guess. So it should be about there. Hit enter. And you can see the point of intersection, my X would be 9.6 approximately. So that means 9.6 hours after you give the medication, you're going to have to give a second dose. I won't go through the other ones. They're similar, it's different information. So you can look through your notes on your own if you want to see examples of a linear regression or a cubic regression. And that is it for today. Have a good day.